Hi, everyone. Welcome to today's webinar. Today, we are so excited to welcome Mason from Source. Source is a deep tech material science company founded in Florida in 2021. The company specializes in creating natural chemistry solutions to enhance the durability and resilience of products. Source has developed three flagship products currently focusing on improving textile-related applications, such as the dyes and fabrics. Their innovative approach has attracted attention from National Science Foundation for its transformational impact and also secure 1.45 million in pre-seed fund from Boost VC in 2023. So today, Mason will share about Source journey regarding their inspiring commitment to sustainability and how they perceive the future for sustainable chemistry industry. Please join me in welcoming Mason.
Thank you. Thank you for having me. I appreciate it.
To kick things off, Mason, I wanted to know a little bit more about you. Could you introduce yourself to the audience?
Sure thing. So I'm Mason Mincey. I'm the COO and co-founder of Source, where we're on a mission to replace the millions of hazardous chemistries we interact with on a daily basis. My background is in material science and engineering, so that's where I got my degree in from the University of Central Florida. And I think the journey really started for me in the business, really on the back end of our first startup. So my co-founder and I, we formed this startup during our freshman year of college, pretty much, where we manufactured high-performing composite materials. So think of materials like carbon fiber, fiberglass, and we started to look at more natural materials like flax fiber and hemp fiber. And pretty much what this business focused on at the time was taking these technical fabrics and then you mix them with resins or glues in a way. And when you mix these two components together, you get this rigid panel-like material, which is formerly known as a composite. So these materials are ubiquitously used in very performance critical applications. So like automotive interiors is a huge area, marine vehicles. And at the time, we were really focused on manufacturing and selling these materials to the drone industry. At the time, we were selling these composite materials to make racing drones. So that was an entire industry many, many years ago, where these were very high performing acrobatic drones and lightweightness was a key need of the vehicles. And composites are mostly known for being strong, high strength, and lightweight materials. So, I think it was a good experience. It got our feet wet in business. We learned, everything from taxes, sales, distribution, how to sell to distributors, and just growing a team. And although it was a great experience, I think our team really understood we can do more, especially with what we knew at the time. Especially my co-founder and I, we both studied material science together. So we were actually lab mates while we were building our first startup. So on the tail end of the first startup, we joined a research group at the University of Central Florida, where we were pretty much doing what we did in our startup at the time, but very much focused on new innovative material systems. So we were making ceramic matrix composites, ablative materials, and a lot of these materials were used for heat shields for NASA. So, we led a group at the University of Central Florida that directly helped commercialize some of the things going on in the lab directly into industry. And one of the most notable experiences that played a role in my development to running this company today was our partnership we had with NASA at the time at the University of Central Florida. So we were helping develop these heat shield materials, very high temperature withstanding materials for NASA. We were making hydrogen fuel tanks for NASA, the heat shields on the outside of some of the aerospace vehicles. So it was a really, really good experience. And at the same time, we had a very large focus in that lab around nanomaterials. So these are kind of like, the wonder topic for material scientists, very, very small scale materials that can do a lot. So we use your classical materials like graphene and carbon nanotubes, and we were developing new coating materials with these nanomaterials. So it was a very, very fascinating area for us. And during this time period, we wanted to see how we can leverage what was possible with nanotechnology. But at the same time, we realized that producing some of these nanomaterials had two main issues. One,
Mhm.
the cost to produce these materials was quite expensive. Typically, you
Mhm.
had to, um, you know, in a way, like grow these materials, for lack of a better term,
Mhm.
which made it just very non-scalable. And at the same time, typically the inputs were quite hazardous.
Mhm.
So that's pretty much kind of the problem that we really wanted to look at the time. And eventually that ended up turning into what is our business today, where
Mhm.
we went on this kind of year-long sprint of saying, okay, like what are some ways we can develop high performing materials that are natural and non-toxic in origin?
Okay.
And that's when we came across this material called nanocellulose. So pretty much cellulose is the most abundant biopolymer on the planet. It's pretty much found in almost every plant on the planet,
Mhm.
terrestrial and both marine.
Mhm.
And when you take this cellulose material
Mhm.
and you pretty much break it down so that it's 10,000 times smaller than a human hair, you get a material that's 8 times stronger than steel. It's lighter than steel, and you can convert it from so many different feedstocks. So all that to say is a lot of that experience, many years ago really
Mhm.
helped culminate to what we're doing today. And then at the same time, I worked a short position at a company called the Textile Exchange, where pretty
Mhm.
much I was creating reports for some of the largest fashion brands and textile brands in the world. So I was lucky enough to get a report under my belt while I was there. It's called The Future of Biosynthetics. If you haven't read it, check it out. Spent a lot of work
Okay.
on it. And so that went out to a lot of the major apparel brands, and that really gave me insight as to specifically the problem space just in the textile industry, just because they consume
Okay.
25% of the world's toxic chemicals every year. So all that to say, those are a lot of my experiences that led up to what we do today.
Awesome, awesome. Thank you so much for sharing your journey before, especially working in the material science. Definitely have been setting up a very strong foundation for you get step into Source. Wanted to get into Source a little bit. At the very high level, what does Source mean to you? And then what is the core mission vision of Source? And then what makes Source unique?
Yeah, so I think what Source really represents to me, and I think the general team, is a company that is on a mission to produce completely natural, non-toxic, high-performing materials at an industrial scale. And I think we're trying to do this on a level that is a little unprecedented in the sense that, it's not like natural materials, natural chemistries aren't a thing. I think what was interesting about what we're doing at Source and why, I'm spending, many years of my life to work on this is because being a material scientist, we are kind of the first at bat when it comes to what are the core problems that we face as a society when it comes to our materials. So
Mhm.
many material scientists, they work on battery technology. So this is, obviously very prominent in the world of electric vehicles, electrification, energy generation. Other material scientists, they work in polymers, so plastics. So,
Mhm.
what's front of mind for those material engineers is how do we stray away from synthetic plastics? How do we make things that degrade easier? How do we make natural materials perform better? So I think for me, I've always, had this kind of bug of wanting to, operate a startup and kind of put our own ideas into the world. And I think this one for me just made a lot of sense for something that could have impact on such a global scale. And it
Mhm.
still resonated with my interest in material science, which is we worked in a rocket laboratory at the end of the day. Like, we made high performing materials. So when we came across this material called nanocellulose and we started to see how it can be such a high performing material, it just made sense of thinking like, 10 years, 20 years in the future, this material can power so many different products and industries
Yeah.
that a lot of synthetic products are used in today, or in industries that synthetic products can't even compete in. So this is like, it's to us, it's we're introducing like a wonder material from a natural feedstock. So when it comes to, imagining a future where we have more renewable resources to make things, to run society on, this is kind of the material that we thought would be the one. And there's so many different biomaterials, like I said, out there, but this one in particular, it just seemed like the world can really run on this material. And in a high level, what we do as a business is we're producing this material and on a mission to produce it globally. And we've developed a refinery process where we can enter in any kind of biomass. Particularly, we work with seaweed and other agricultural waste, so very high CO2 storing plants. And we convert that with our process where we can, extract that nanocellulose from the biomass and tune it to perform like we want to. So I think that goes back into that global piece, right? Which is
Hmm.
not only can we produce this nanocellulose, but we can also tune it to behave like we want to. And that's really what's necessary to really push a material like this on an industrial scale. It has to be compatible with so many different chemistries, so many different industries. So in a nutshell, that's really what we focused on as a business.
Awesome, awesome. The way you're describing the mission that we have, and also the excitement that you have, I can see your firm belief in this product that you've been developing, and also your commitment towards it. That's awesome to see that we have been hit the ground running, and then we have been seeing things coming through. So we wanted to get into a little bit more about the source, especially the product that you've been mentioned. What could you give us the what is the product, and then what made the product stands out, and what is the before and after for some of the clients that you've been using the product looks like?
Yeah, so primarily, we have two main products that the company produces, and
Hmm.
then within those two products, we'll sometimes make final formulations. So pretty much what this means is, of those two products, for example, one of them is a chemistry called Seabind. So this is a seaweed nanocellulose material. And then sometimes what clients will require is if they require, certain unique properties, we'll adjust that formula to make, what we in the industry call final formulation. So this is something that the customer can buy. It's already designed to perform a certain way. So the customer doesn't have to, finick and mess with it to get it to be what it wants. And that final formulation we have so far is called ceramic. So this is almost like an upgraded version of Seavine. And then our second product is TerraSolve. So this is a solvent that we developed in-house, and it has like a dual use, I would say, where TerraSolve is a natural solvent we developed that we use in our refinery process to both extract and functionalize or tune
Hmm.
that cellulose from the seaweed. So that's what the TerraSolve is used for. But at the same time, in an effort to use as much as we can from our production process, we actually figured out a way where we can take that TerraSolve chemistry we use to actually, get the nanocellulose out. We can either recycle that back into our manufacturing process, which we've
Hmm.
done. We've seen you can do it around 2 to 5 times with still good extraction efficiency.
Hmm.
Or once you've separated that solvent TerraSolve, you can actually use that and sell that off as well for other companies that want to use the power that TerraSolve possesses when it comes to processing biomass. So just to give you some use cases, today in the textile industry, represents 10%, roughly 10% of the world's CO2 emissions. And most of that impacts, roughly half of it, comes in during they call it the processing and treatment stage. So think of, when you get fire resistance on your couch, or you get UV resistance on your apparel, or even the dyeing that goes into your process. All of this is in that like 50% pool of dyeing and treatments and processing in the textile step.
Yeah.
So some of our customers have used Seabind and formatively ceramic as a coating that goes on top of a fabric in that process, and it imparts properties like fire resistance and UV resistance without
Hmm.
relying on some of the chemistries that are under regulatory scrutiny. So some of these include compounds like antimony, which is a heavy metal. So all that to say is Seabind in that case has been used to pretty much provide these like protective properties to textiles that are typically achieved using more toxic ingredients.
Yeah.
And secondly, this is an application we've been exploring more recently, is in the composites industry. So think of like marine vehicles or maybe like a bike frame or a golf club. All these material products use carbon fiber because it's so light and strong. And specifically in the vehicle industry where they use these composites for lightweighting, they have very stringent goals by 2050 to cut the weight of these vehicles to increase fuel efficiency to help them meet some of their ESG goals. So we've had other cases where they've taken our seabind, so that seaweed nanocellulose, and once they coat it on each layer of fabric of carbon fiber before they make it into a rigid composite panel,
Mhm.
it actually helps strengthen the composite significantly, which what that means is if you can strengthen that composite, that means you don't need as many layers to get the same amount of strength, if that makes sense. So what that
Yeah.
means for them is they can create a material that's lighter, which that means their vehicles will be more fuel efficient. So those applications we're really excited for because now you're speaking more like industrial applications of
Mhm.
this high performing material. And then on the TerraSolve products on our line, we primarily have been using that still in like the textile, leather, fashion industry, where we have clients in the leather industry that have used TerraSolve as a way to pretty much drastically reduce the amount of hazardous chemistries that go into their tanning process. So this is pretty much the step where you actually make the leather.
Mhm.
So when they essentially soak the leather hide in Terrasolve, it helps increase the amount of the tanning agents that go into the actual leather hide. So by doing so, if you can drastically increase the amount of chemistry that can go in, you don't really need as much as you
Mhm.
typically do. So we've had a client where we've dropped their chemical use by 98% just by using a small amount of Terrasolve in their process. So overall, a lot of our clients are really across the textile leather industry and now moving more towards technical textiles like those used in sports goods, marine vehicles, so on and so forth.
Awesome. Awesome. I can see there are standardized product where is a very good foundation for you to tailor make some of the features that is needed for different client use cases. And this is great because it's very good way for us to scale it up, especially you mentioned that we wanted to go global. And also it's also a very good way for us to actually industrialize on it.
Mhm.
Also I can see the product itself firstly is sustainable. It's very clean product. It made the client to become more sustainable as well, right? Not only their final product, but the processes in terms of like how they produce the product. And also the way that we trying to produce the product is also 100% clean. We're trying to make it zero waste. So all this come into a really great effort towards sustainability. I wanted to know more about it because I know this should be tons of effort from the team to make this kind of product. Do you meet some challenges along the way and how you overcome those challenges?
Yeah, definitely there's many challenges with building this kind of business. And I think um so I think a good starting point there is defining, kind of two ways or two different kinds of startups, I guess. So I think what VC has been built upon for the past like 10, 20 years is your kind of Silicon Valley startup where, it's a SaaS company, maybe, the B2B SaaS company where you have companies that are solving a demand problem, not necessarily demand and a technical problem, because most of the resources and technology existed to scale those solutions. So I don't want to, downplay at all scale for a software company, but typically, once you can get a large client and you can start increasing your clientele, you can scale as your demand increases. So really, your job at that point is to solve the demand problem. You have to just prove that this
Mm.
product, B2B SaaS product you've developed, is actually worth something. Then you have deep tech companies, and I think where the challenge for deep tech comes in is the iteration cycles are just much longer and much more expensive. And what I mean by that is in deep tech, there's this just well-known term, which is the valley of death, which is even if you have you've identified you can solve this demand problem where this is like a clearly needed product. Let's say it's some new battery technology that is very stable supply chain wise, right? Like we know clearly this is like a product that has large demand to help the transition to electrification. But many times, some of these startups and research, they just can't make it to a feasible stage because this valley of death exists, which is, the funding required to just get a minimum viable prototype. And that by itself can be very expensive. And you don't have enough money to go through these iteration cycles of, hey, we made this, let the customer test it. Okay, let's go back and do this iteration cycle. Like you may only have like two or three of those, right? So it's
Yeah.
a lot more resource intensive, capex intensive. You have to build things, which is it's much tough. It's tough. It's very, very tough to do that. So I think a lot of the challenges really stem from that point where you have to build a physical thing. You have to figure out supply chain. You have to, manage a technical team, but also build this company that makes this technical product into a business. So oftentimes there could be issues that can kill a business, 7, 8 years into it. And it can be something as small as you just couldn't get it as cost effective, or you just couldn't produce enough at the quality that you needed, or you couldn't ship it across the country for these regulatory reasons, right? There's so many different hurdles that go into scaling a manufacturing or a deep tech company that make it really, really challenging, I would say. So
Yeah.
I think the way that we've overcome this is I think our team is good at seeing what's been done in the past and learning a lot from, I don't want to say those mistakes, but I think when you're first at bat for, a new deep technology company, you're the first one to learn. So you're kind of paving the way, whether it's, the good path or the right path or the wrong path, you're paving the way. So I think what we've done really well is we've kind of looked at previous deep tech companies and we've seen how they've grown before. And I think what VCF has seen traditionally with deep tech and a lot of climate tech is there are these like hardware and asset heavy businesses that will raise a ton of funding in the early days, and they don't have, in that process of building the company and raising all the money, they realize the product maybe just isn't as feasible as they thought, or they didn't have the customer demand already lined up before they went to go build that facility. So I think the way that we have, I guess, navigated some of these challenges is I think we're always customer focused as a company. So we have an entire internal process when it comes to vetting customers, and we always think about, will this R&D sprint that we're going through ultimately reflect a business opportunity? And how do we ensure that we're generating revenue as a business, or at least have these development agreements in place before we go build the facility? And I think the last important thing that we've learned, especially I'd say in climate tech, is unfortunately a lot of what we've seen around clean tech, these low carbon intensity materials, is sustainability sometimes just doesn't cut it enough to replace, some previous material, especially if this, lower carbon material you developed or product you developed is absorbently higher cost than what was on the market. So I think we've just seen historically a lot of customers aren't like buying into that anymore, especially when you're like an asset heavy, very material heavy business. I think what's most important is that is just an expectation as a climate tech company is you have to ensure that what you're making is ultimately clean and you're going through the proper assessments to know that you're adding some sustainability impact. But you always should focus on solving some quantifiable problem for the company first. And I think producing what we are as a company, nanocellulose, this very high performing material, I think we're always in this mindset of what is the performance gain? What's the value gain?
Yeah.
We just happen to have a material that helps you meet your sustainability goals, or that our production, we make it as clean as possible. So that I think navigating that, I think, has put us in a better position, but we still have many years to go to grow the business.
Yeah, I can resonate that very well. I think one of the biggest problems that we're seeing for sustainability is for the companies, they haven't seen enough return out of the investment of sustainability. So how best we can measure, let you sorry, quantify the results is very important. Like what exactly they're getting out of it. It's not only the tangible like revenues or cost saving, but there's also like very important intangible like return there. Like how we can quantify even that could be very important.
Hmm.
And then yeah. Also within like the end users, let's say the general public, we will want to see more that they cares about sustainability. They incorporate sustainability into the decision making process. And since the end user consider that, that could be a more important driving force for the companies to produce more sustainable product. And then you also mentioned you're very customer focused, and also that is very important because at the end of the day, we want them to use more sustainable products. Wanted to ask a little bit more there. How do you vet the customer? How do you shape up like partnership? And what is the like strategy we have over there, and how like what is next? Let's say for us for Source.
Hmm. So I think it's been very iterative, our business development process.
Mhm.
I think a big part of our process really starts off with just a general, like, what is the market opportunity with this industry? So the
Mhm.
thing about specialty chemicals and materials is, although these materials, so in general, right, if we think of the specialty chemistry industry, right, so that's like
Mhm.
$850 billion market cap of an industry. So there's
Mhm.
billions of dollars of these specialty chemicals sold every year. So you would think of that TAM and assume, okay, this is like a very massive market. But the thing about the specialty chemical industry is it's made up of thousands and thousands of different chemistries. So when you start to
Yeah.
split this out a little bit, you'll have many opportunities, or you'll see many scenarios where you have a use case of a specialty chemical, but the actual like use and purchase volume of that specialty chemical for this specific use case may be, sub, $600 million market opportunity, which, from like a VC perspective, right, they'll see that as like that's not really large.
Mhm.
And especially when you're building this kind of business, unfortunately, at the end of the day, you have to make sure that, the opportunities you go into are large enough markets where it makes sense for VC, until you can get to the point where you start getting into that project financing stage of a business where it's a combination of different financing vehicles that can really help you.
Mhm.
But I think it really starts with just understanding, like, what is the market opportunity of using this specialty chemical in this market? But then
Yeah.
also, once you start to identify a certain opportunity, then it comes down to, okay, like we really need to quantify the value. And I can't stress that enough, of like quantifying the value for, chemical companies, new material companies, because I think it could be quite um, it can be quite challenging if you aren't looking at it from a techno-economic analysis standpoint. So
Yeah.
what I mean by that is, if you look at a certain opportunity and you say, okay, they are using XYZ chemical and it's costing them this much to run their process today. And then you insert your business and say, okay, well, if they add our chemical or our material, we increase their cost by X amount, or we decrease their cost by X amount. That fundamental exercise is just so important, because at the end of the day, like, the chemical industry is almost completely driven by cost, unless your performance gain is significant. So that's like the main game you play there is, okay, based on this TEA that we did, if we're more expensive, then in this decision tree, we have to look at, well, what is the performance gain? What's the value gain? And quantifying, the economics of this opportunity isn't only on just material side. It could also be on, a regulatory side, right? So if they aren't
Yeah.
using a hazardous chemistry anymore, maybe they're saving on hazard waste costs. So that's why this can be
Yeah.
kind of like a challenging exercise, because there's so many parts of this
Yeah.
waterfall that you have to look just beyond the cost. So I would
Yeah.
say, to summarize, what goes into our business development process is we always think about what is the value waterfall of the opportunity. And by waterfall, we mean, what's the cost of our material for them? Is it added
Yeah.
cost to them? Is it lower cost? Is it parity? okay, then where do we provide value through this waterfall? Do we save them on hazard waste management costs? Do we save them on material storage? Can we decrease their labor costs? So it's everything all included that
Yeah,
goes into that process. So business development for a chemical company can sometimes be like a tedious process and a little longer than
yeah,
you would like. And I think we're
yeah,
still learning on how to make it faster. But I think it does take it should take good care in the process to really understand like what is the true value that we're providing, and can we really understand like the cost of integration, because once you start going down the path of working with an industry and a client and you're trying to get the product to work, that
mm,
can take just so much time. It can take so much time.
yeah,
And everything in a company like this is what's your man hours that you have in the lab and production to fulfill on an order. So every time you add a new client, or especially like a new market opportunity or a new application, right? You're adding potentially like months of technology development just to verify if it's going to work for that client.
yeah,
So, you have to be really laser focused on where you spend your dollars when it comes to your time for each application. So, I think, like I said, we're still getting better at it. I think we're learning how to be even more laser focused as a business. It's definitely very difficult, considering you have to manage the technical side as well. But I say we're getting there, and I think what's on the horizon for us is really starting to push our product into more industrial markets. Because as we've
mm,
gone through this analysis, we started to see, because we make such a premium, high performing material, we
yeah,
should try to push these in markets that have just a much higher budget for these new material innovations,
yeah.
because their products are sold at a premium. So that
Yeah.
exercise we're going through right now.
Awesome. Awesome. I like the data-driven approach whenever you mention quantifying and then measuring along the way. For one, it is very important for us to track the performance and also like monitor it, right? If it is like higher courses, lower course. Yes, a lot of these you may take time for the outcome to realize. So that's something very important. And the other thing I think is very important is like keep the confidence level for everyone who is being in the journey together with us. They need the transparency and then also like keeping up their confidence with us, so then we can work together with them for the whole journey. So I think that is
Mm.
also very important. Um, I wanted to ask a very final questions, Mason here. So this is a new year, 2025. What is the New Year resolution for you guys? What you wanted to achieve for 2025?
Yeah, it's a good question. I'd say there's a lot of things on the horizon for the business, but
Mm,
I would say, what's really most important this year is, these last few years of the business, I would say, have been very heavy on the R&D side. So we've been spending a lot of time actually developing the technology, and we've gone through pivots as well based on how
yeah,
we can make the material and the markets that we should go into. So I'd say this year, big focus is how can we, get the material into, the most amount of very
yeah,
prominent businesses as possible. So, the huge focus of this year is having a team and a production process that we can use to really tap into some of these markets that we feel will generate the most value. Because I think this year will be the most critical in
yeah,
terms of the business moving forward. Because
yeah,
this year will be just a huge focus on business development. Like I said, the last few years have been very techno economic heavy, technical development heavy. But I think this year we're now applying all what we've been developing, and we've been working with clients very closely. And now
yeah,
we're at the stage where we can start producing more of this stuff. So a big thing this year is we're getting this new facility up and running in the next few
awesome.
months here. So that'll be a whole thing. And then once we're up and running, it's really just spread the message of Source wherever we can. And what's really important for us as a business is branding. And I think
Mhm.
branding is important for us because, being a chemical company, you're still making materials that go into end products for consumers in a lot of
Yeah,
cases. So I think um, for a business like us to exist, I think the world also needs to understand, this is a thing. This is a
yeah,
business that exists, and this is a technology that's reaching the masses. And I
hmm
think that kind of transparency of oh, I know what material went into my product, right? And I know this whole story of like how seaweed was converted into this. That excites me a lot. I think,
Yeah,
one of the most exciting things about the business is being able to take everything that we've developed and turn it into a narrative that people can really just enjoy and,
yeah.
you know, get people excited about science and materials, and get people just really interested in, what's really possible with technology.
Yeah, awesome. And also when we get to more clients, customers this year, we also will be able to like speed up the iteration process that you mentioned. So I really looking forward to more and more stories from you and also the team. And thank you so much for joining us. It's been great getting to know you and the Source team and also the amazing products. And then thank you for everyone for joining us.
Of course. Thank you so much for having me.
All right.